Hi, my name is Jonathan Lambert, and today we will discuss converting raw qualitative data into a frequency table. So today's session will cover converting raw qualitative data into a frequency table. Okay. So let's say we perform an experiment. The experiment is a simple experiment where we ask a number of people what their favorite color is. Let's say the first person says red. Let's say the next person says blue. Let's say the next person says blue, green, yellow, red, yellow. Let's say the next person says green. Let's say the next person says red. Next person blue, next person red, let's say the next person says blue, and let's say the final person responded with a value of blue. Okay, so this is raw data, it's raw qualitative data. The responses were non-numerical, so it's qualitative. And if we want to produce a frequency table of this raw data, well, let's remember that a frequency table is simply a two-column table. So it's a table with two columns in it. Okay, let's say the first column is down here. Okay, the first column typically represents the variable that we were measuring. In this case, we were interested in favorite color, so a reasonable name for the variable would be color. Okay. The values that the variable took on in the experiment were red, blue, green, and yellow. Okay. Okay, so frequency table, as I said, has two columns. The first column represents the variable, and listed under the variable name are the values that the variable takes on. The second column represents the frequency of occurrence of that variable in the experiment. Okay. So we can see that red occurred once, twice, 3 times, 4 times in this experiment. Blue occurred once, twice, 3 times, 4 times, 5 times in the experiment. Green occurred once, twice, and finally yellow occurred once, twice in the experiment, giving us a total of 13 observations. That is, we asked 13 people the question, what is their favorite color? Okay, and that's a simple frequency table. What we can also do is we can create what is known as a relative frequency table. A relative frequency table just consists of another column. Okay, we typically represent that by R. Okay. And in this particular column, what we do is we list down the values for each variable relative to the total. In other words, how many observations for each variable occurred relative to the total. So what we can see for the first variable, red occurred 4 times out of 13, so that represents 4 of the 13 observations, which gives us, as a decimal, gives us 0.31. Blue occurred 5 times out of the 13, so it represents 5 13ths. Which gives us a decimal 0.38. 2 occurred twice out of the 13 observations, so as a fraction of the 13, it's 2 of the 13ths, giving us 0.15. And finally, for yellow, which is 2 again, 2 frequencies, 2 observations, that occurred 2 of the 13 times, which gives us 0.15 again. Okay. So now this is a relative frequency table because we have the relative column in there. We can take one more step and we can create what's known as a percentage frequency table. And the percentage frequency table represents the number of observations for each variable value as a percentage of the total number of observations. Let's keep in mind that we can always convert from a decimal to a percentage simply by multiplying the decimal by 100. We can convert from a percentage to a decimal simply by dividing the percentage by 100. Okay, so as a percentage of the total, relative to the total, 4 observations for red represents 4 13ths of the observation. If we multiply this by 100, we get the relative percentage, which is 0.31 by 100 gives us 31. So 31% of the observations were red. Looking at blue, well, blue occurred 5 times. As a relative frequency, that's 0.38. If we multiply 0.38 by 100, that gives us 38. So blue occurred 38% of the times in this experiment. Green has a relative frequency of 0.15, multiplying that by 100, that gives us 15. So green represents 15% of the observations. And finally, yellow has a relative frequency of 0.15 also, multiplying 0.15 by 100 gives us 15. And if we sum these up here, well, due to rounding, rounding here with the decimals, I suppose this comes in at 99%. So it comes in around 99%, which is okay in this particular instance. Okay, so this particular talk covered converting raw qualitative data into a frequency table. We have raw data. The frequency table has two columns initially. Okay, the first column is the variable that we're measuring, and we list under that the possible responses or the responses that occurred in the experiment. The second column represents the frequency. Okay, that's how many times each variable occurred in the experiment, and we can see that red occurred 4 times, green occurred twice, and so on and so forth. Then we can convert the frequency table, where we have the raw frequencies, into relative frequencies. That's each observation of the variable relative to the total. For example, we can see that blue occurred 5 times, which represents 5 of the total 13, which is 5 13ths. 13 divided into 5 gives us 0.38, rounded to 2 decimal places. Okay, so that's relative, and then we convert to a percentage. It's straightforward to convert from a percentage. Once we have the relative frequency, all we do is we multiply by 100 to give us the percentage frequency. And we can see here is that blue occurred 38% of the time, green occurred 15% of the time, and yellow occurred 15% of the time. So that concludes this talk on converting raw qualitative data into a frequency table. Thank you.